What's up, everyone? Today we're beginning chapter 5, and this is a chapter on quadratic equations and quadratic functions, okay? So in this first section, we're just going to be identifying what it means to be a quadratic function, as well as how we can graph a quadratic function when it's in standard form, okay? So the standard form of a quadratic function is going to look as follows. You're going to have y equals ax squared plus bx plus c, where the values of a, b, and c represent any real number, okay? Now, what makes this a quadratic function is the fact that you have that first term of ax squared, where the power on the variable is 2. So that's known as your quadratic term. And then the middle term of bx, that's your linear term. And then c is constant, okay? Now, any equation of this form, the graph of it is going to be a parabola, okay? Which sort of takes on a U-shaped appearance. So it's the blue curve that you see over on the right here. This is a parabola. Um, it will have a y-intercept at the point 0c, which is nothing more than the constant term from your equation. And then notice it has an axis of symmetry to it. So this is the vertical line that is literally dividing the parabola in half. And we have an equation that we can use from our formula for the function to find that axis of symmetry. It would be x equals the negative of the b value from your function divided by 2 times the a value, okay? Now also notice the parabola has a vertex, which is in this case, it's the lowest point on the curve. And the vertex is, well, the axis of symmetry is passing through the vertex, right? So that means that the x coordinate of the vertex is going to have the same value as that's defining that axis of symmetry, okay? So I'm going to say for the vertex, the x coordinate would be the point of negative b over 2a, and then the y coordinate would be the function evaluated at negative b over 2a. All right, and understand I can use function notation here because this parabola is representing a function. It passes the vertical line test, right? So up here, instead of just saying y equals, I could have said f of x equals, okay? All right, so let's get right into an example here. We have a couple different parabolas that are graphed here, and we just want to identify some key characteristics. So we want the y-intercept, the vertex, and the equation of the axis of symmetry for each of these, okay? So let's start with the parabola on the left that is opening upward. You can see it has a y-intercept at the origin, okay? And then its vertex would be this point down here, which has coordinates of 3, -9. And then the axis of symmetry would be the vertical line that's passing through that vertex. And that would simply be the equation x equals 3. Okay. All right, my second parabola is opening downward. It has a y-intercept at positive 3. That's the point 0, 3. The vertex is right here at negative 2, 7. And once again, your axis of symmetry has to be the vertical line that passes through that vertex. So this would have the equation of x equals negative 2. All right. Now let's graph a parabola when we're given its equation for the function, okay? So graph f of x equals 2x squared plus 4x minus 3. And then once we have it graphed, we're going to identify the domain and the range, okay? So first thing I would do here is I would identify my a, b, and c values. The a value is the coefficient on your squared term, so that's 2. Your b value is the coefficient on your linear term, which is 4. And then your c value is always the constant, okay? So we're going to begin by using that formula for the axis of symmetry. It's x equals negative b over 2a. So for this particular function, that would be negative 4 over 2 times 2. And that's going to simplify to negative 1. Okay, so right away I can tell you the symmetry is taking place over this line. Okay, all right, now I'm going to make a table of values, and I'm going to choose the values for x that I'm going to evaluate f with based on this value for the axis of symmetry. So in this case, it's negative 1. I'm going to put that in the center of my table. Okay, so this guy is going right here in the center. The reason I'm putting it in the middle is because it literally is going to be thought of as the middlemost value of the associated parabola for x. Okay, and then I'm just going to choose a couple values of x that are smaller. So negative 2 and negative 3, a couple values that are larger, 0 and 1. And I'm going to plug each one of those into the function for x, and I'm going to simplify. Okay. When I do that, I have to make sure that I follow order of operations. So just be careful about that. Okay. So when you plug negative 3 in for x, that should simplify to a value of 2. When you plug negative 2 in, that should simplify to a value of negative 3. When you plug negative 1 in, you should get negative 5. When you plug 0 in, you should get negative 3. And when you plug 1 in, you should get 2. All right. And I want you to notice that these are the same values. That's based on the fact that we have symmetry across the vertex of negative 1, negative 5. Okay. So let's take a moment to plot all these. And here we have our curve. Make sure when you draw this, you kind of round it off at the bottom there. Don't make it come to a point. These are not V's, all right? They are rounded near the vertex, okay? And then we're going to identify domain and range now that we have the graph in front of us. The domain is all real numbers, which is the case of any parabola, okay? Now the range is going to be based off of the vertex, specifically the y-coordinate of the vertex, this and the fact that this parabola opens upward. So for this parabola, it would be from negative 5 to positive infinity, or we could say any value greater than or equal to negative 5 for y. Okay. All right, so your first practice problem is going to be very similar to this example. All right, if you get stuck, just come back and reference this one. Pause the video here for a moment, work through that, and then come back and check your work with mine. All right, now I want to talk about the maximum or minimum value of a quadratic function. Okay, when we say find the maximum or minimum value, that's referring to the largest or smallest y value of a function. All right, so for a quadratic function, this value is always going to occur at the vertex of the parabola. All right, so specifically it's going to be the y-coordinate of the vertex. All right, and it's really easy to identify when you have the graph in front of you. But if you don't have the graph in front of you, it's helpful to know the following, and that would be that a parabola is going to open upward, meaning that it will have a minimum value. The vertex will be the lowest point whenever the a value from your function is greater than 0. Okay, so if we focus on this value right here, as long as it's positive, that tells me the parabola is opening upward and we have a vertex, or we have a minimum value, which is the y-coordinate of the vertex. Okay, and if a is negative, so less than 0, now my parabola is opening downward, which makes the vertex the highest point, so we would be having a maximum value of the y-coordinate of the vertex. Okay? All right, so based off that, does this function f(x) equals 1 plus 8x minus 2x squared have a maximum or minimum value? Okay, well, your a value is what you'd want to focus on here, which in this case is -2. All right, now that is a negative value, okay, which means your parabola is opening downward. A is less than 0, so parabola opens down. Which means that your function is going to have a maximum. All right, now how do I find that maximum? Well, I simply need to know what the vertex of this parabola is, okay? So I'll start by finding the x-coordinate of the vertex, which I can use the formula x equals -b over 2a. So in this case, -b would be -8. 2a would be 2 times -2, so this is going to simplify to 2. And then I'm going to evaluate the function at that x value of 2. Let me show the work on that. All right, so follow order of operations. 2 squared is 4, 4 times 2 is 8. 1 plus 16 minus 8 gives me 9. Okay, so the vertex for this parabola is the point of 2, 9. And the y-coordinate specifically is going to be your max value. Okay, we're focusing on the y-coordinate here because when we're talking about maximums and minimums, we're talking about high and low values, right? Which are controlled by the y-coordinates of your points, okay? Now here's how I would like you to write your final answer, if you will. So I would say that f of x has a maximum value of 9 at the x value of 2. Get in the habit of writing it in that format. Okay. Now a bit of an application here. All right, so we have the daily revenue R achieved by selling X boxes of candy is figured to be the function R of X equals 9.5x minus 0.04x squared. So notice this revenue is being represented by a quadratic function. How many boxes of candy must be sold to maximize revenue, right? And then what's the maximum revenue, okay? So understand kind of the makeup of this function, right? It's telling us that we've got a parabola that's opening up and then coming back down. I know that it's opening up because my a value is negative here, okay? And understand your vertical axis is representing your revenue and your horizontal axis is representing your boxes of candy being sold here, okay? So again, we want to figure out how many boxes of candy must be sold to maximize our revenue, and then also based off of that, what's your max revenue? So we are simply trying to find the coordinates of that vertex again, right? It's going to be the highest point where the revenue is at its greatest, right? So let's use -b over 2a, x equals -9.5 over 2 times the 0.04, and that should equal 118.75. And understand what that means in the context of this situation. It's an X value, which represents boxes of candy, okay? So you're going to make the most money by selling approximately 118 boxes, 119 boxes of candy, all right? Now, what is your max revenue? Evaluate the function with 118.75. And if I round to 2 decimal places, since we're dealing with money here, that's going to be $564.06. Okay. All right, so we're going to write a sentence here to formulate our answer. We're going to say the maximum revenue would be about $564.06 by selling 118 boxes of candy. Okay.